one thing that I think you should definitely, if you're a tech leader, invest your time on and maybe some resources is creating dedicated data science internships, right? I mean, you're trying to identify talent for sure, and that's a great way to do it. But the nice thing about that is that this is the first time, if you are good at that and incorporating interns into the everyday work of a data scientist or a data science shop interacting with machine learning engineers and all these things that we talked about, then these people all of a sudden just, they get the aha moment of like, oh my God, this is the whole thing of doing all of this, right?
Hey everyone, I'm Debbie Madden. I'm the host of the Scaling Tech podcast. Today I am so excited to talk to Marco Morales. Hey Marco, how are you?
Hi, Debbie. Thanks for the invitation. I'm really excited to be talking with you today.
Awesome. We're talking about a really interesting topic, and we're going to call it, it's going to be very exciting framing, and you're all going to be really excited for this conversation. We'll call it Data Science Decoded, the Academia versus Industry Showdown. Because Marco and I were talking at an event the other week about, well, there are a lot of differences, right, in academics versus business. And so we thought we'd share that with you. So before we jump in, a little background on Marco. So Marco has spent the last decade at the intersection of business and technology, leading and building corporate data science shops in media and entertainment, most recently including Warner Music Group and NBC Universal. So names we've all heard of. And you wear a dual hat as a faculty member at Columbia University and Columbia Business School, where he teaches graduate courses on data science to social scientists and technology to non-technical MBA students. Amazing. And also, you are currently on sabbatical from industry, and you're writing a book about the playbook for successful data scientists in business. So suffice it to say, you've come at this from multiple angles, and I'm really excited to jump in. And so, let's just start with framing this conversation. Data science, it's had an impact on business. It's, I guess, relatively new, though not new. And at one point, it was even called the sexiest job of the 21st century by Harvard Business Review, which is interesting, and I can believe that.
Right.
But in the academic world, it really is different. Like we would say, radically different from the practice of data science in business. And why are we talking about this? Is because that there's a gap. You get all these up and coming next generation of data science coming out of academia, graduating with degrees, and then they get thrown into business. And so I want to talk about what the gap is. But first, let's start with tech leaders generally are the ones that listen to Scaling Tech podcasts. And so why do tech leaders want to care about this topic?
I mean, thanks, Debbie. That's a great question and probably one of the best starting points for this conversation. So I think the gap is really important just because, what you want as a tech leader when you are hiring people from data science, just graduating from data science, or people that like me, at some point did a graduate degree, I did my PhD, and then all of a sudden one day I was stepping into this role. And what you find is that people don't usually can hit the ground running, right? So there's a learning curve that people incur in the job. It's a cost that any company ends up incurring, for getting people ready to be contributing as just data scientists on the job. And, it's an investment that's kind of short-lived because according to the current trends, people stay on data science jobs 2 or 3 years in a particular company. So you invested in that person, and then, they will, they might move away. So, it's, I think, an important thing just to be very, very mindful. And there are things, and we can talk about that later, that you can actually do as a tech leader to mitigate some of these factors that we have right now. But I think it's just important that, a lot of people coming out of academic programs might not be able to just hit the ground running the way that some very experienced person might be. And that's important.
Yeah, absolutely. And I've seen similar trends with other disciplines that are, I would say, something like user experience, UI, UX. I found a similar gap. and even back 10 years ago, product management. And so I'm not surprised to hear you say this. And so now let's get into a little bit of the details. So, like, how do the methodologies and tools used in academic data science differ from those used in a business, like to cause that gap that you just talked
That gap.
about? So, like, yeah, how are these concepts being taught? And answer that. That's a very broad question. So dive in how you see fit.
Right. No, I mean, I think it's probably key, for people to understand what the difference is, and I think one of the points that you were making is probably a good foundational contextual aspect, which is data science is a relatively new field, and people don't really have the whole playbook. Just as when you were doing PMing for the first time, you knew certain things, but you were figuring out other things, and eventually that made it back to academia. So the way that we are teaching every technical aspect of data science is very focused, right? And in very clean aspects, if you will, right? I mean, you are focusing on the outputs, but you don't really do much about the contextual things. What do I mean by this? What I mean is, for instance, you are teaching somebody to do machine learning, and you're using really advanced machine learning models, maybe deep learning. Maybe you're teaching somebody how to build an LLM, a simple one. And what you teach them is just the very technical aspects, but you don't care too much about the data. You don't care too much about the fact that that's going to be deployed someplace. You don't really teach so much about once this is done, you will be handing it off to somebody else. Even before we start with this, the first question is not is the why are we building an LLM? It's just like we're building an LLM when you teach it. So is this the right way to go through this problem? Is this going to solve the problem, or is it just going to create something else? So it's a little bit of a disconnect from the very beginning of how do you evaluate the question? How do you evaluate? Is this the right question that you're answering? Is this the right problem to be solving? Is this the right data? Does it have enough signal? Is this just the best algorithm that you could use? What is the process to actually do some deployment? How do you hand off things? Like you're prototyping, you're a data scientist, you're prototyping, but you need to hand it off to a machine learning engineer, maybe to optimize it because it's a large language model, or you need to connect it to data pipelines. Like how do you do all of these pieces? And at the very end of this whole process, also you need to be thinking about is this a product that will be adopted really? It's sort of like it's not just the dream, the field of dreams fallacy, right? I mean, I built it, they will come. It's really
Right.
not just that. You need to think about, is this too complicated for my users? Is the age group different? Do these people are they tech savvy? And then how do you evolve this, right? I mean, like obviously a product that just stays there in the shelves without ever evolving, eventually loses its luster and its value. So all of these things are things that we really don't teach when when we're teaching, because the focus is on the technical aspects of things. So the gap then is all of these things when you hit the ground, when you go into your first job, it's like, oh my God, I had no idea. I didn't know why this was the case. I didn't know that I had to collaborate. I didn't know that, or how to collaborate. I didn't know how to interact with people that aren't technical. Wait, you mean that not everybody speaks my jargon? Like, wait, so it's all of these things that I think are creating this gap. And it starts with, a very rightfully useful way of teaching, which is we teach in controlled environments so that you can actually learn the technical aspect. But I think we're still, the gap is with, now that you know the technical, how do you apply the technical, right? I mean, it's a bit of the way I think that most programs were crafted is as technical programs, not as professional practice programs for data science, and that creates a gap.
Right. And obviously everyone listening knows that real data is not clean. It's the whatever the opposite of clean is: messy, complex.
Right.
um, uh, and so we talked a little bit at a high level about the differences, and I'm wondering how do you teach, the approach to problem solving? Because the data, so you're coming out with the clean data, and that's the right way to start. You can't,
Right.
the first way to expose someone to this is not, oh, here's the worst case scenario. You need to start with the best case scenario, which is a clean data set. Um, but then, your first job, like, I can't imagine, unless if you're going to a startup from scratch, like, any existing data is immediately going to have complexities or errors or confusing bits to it. And so how do you approach the problem solving aspect of data science in academia, and how does that compare, do you think, what happens in the job setting?
I mean, that's a great question. I mean, I think there's a three big elements that maybe we can talk about, right? I mean, the first one is uh, the data itself. There is this thing in data science that says, essentially, you spend 80% of your time cleaning data and making sure that the data is appropriate, and about the 20% building everything else.
Oh,
And that might be true of other disciplines as well. But it's not just about, is my data clean? Is my data free of missingness? Is it not corrupted? I think there's a different aspect in addition to data science that relates to the problem solving aspect, which is, okay, uh, now that I've figured out what the right problem to solve is, does the data that I have is the appropriate data, right? I mean, and there's multiple examples of this, but let me just quickly summarize. The typical example that you find as a data scientist. You're working for a company, and somebody tells you, "Hey, we have this massive database, super rich in data of all our customers, and we need to grow our customer base. So go do something with that data to grow our base." And it's a great question, but the real issue is, okay, but there is something very specific about your customer base. I mean, there is out there, I'm sure, people that look exactly like your customer base, but didn't buy your product. So, what is the thing that causes that people that should be buying your product to buy your product? And there's also other people that don't even look like your customer base and that they're approaching that. If you just focus on the data that you have about the people that selected themselves to buy your product, you might be missing the mark. There might not have enough signal. So, it's a little bit of like, no, no, no. As a data scientist, you have to think about these things and be like, look, there is data. It might not be the right data. And the way to go about getting the rest of the data is rather different. To the question of problem solving, I think the difference when we teach a lot of this, as you were saying, you already, either if you're an academic doing research, you defined your problem, you defined everything, and you're the subject matter expert, and you do it without consulting anybody. If you're a student, somebody told you exactly what you're doing without worrying about the context and not doing anything. When you are in the real world, you can't just start doing that. The first person that you need to talk to is the people that are being affected by the problem or the need. And you need to have a conversation and understand whether, I usually think about, this whole idea of the five whys,
right.
like, okay, if somebody tells you this is the problem to solve, like, okay, what caused this problem? Why is this a problem? And then, you go further back and you usually find out, the root cause of the problem, and then you go there. But as a data scientist by yourself, you're not all knowing. You need to work with the rest of the company in order to understand the problem. So there is a very, very, very radical difference when even when you're trying to define the problem. It's either somebody gives it to you and you're used to that, and then when you come for the first time to industry, you're like, no, 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 I know best. You just sit back, relax, and enjoy the ride because you're gonna see me in action. And it's never like that, right? I mean, you need to bring everybody else as maybe the pilots or the co-pilots, and you just sit next to them and try to figure out what the problem is, right? I mean, it's a little bit of almost like PMing in a way that needs to come into the mentality of data scientists.
Interesting. Yeah. So in an academic setting, is it are data scientists typically working with other data scientists, or like who does play these other roles? Like, is there someone filling that equivalent seat to teach them how to interact with, like, the product side, or is that kind of just absent from the educational part? And they're all kind of in this world with other data scientists, and then they see like the product side and the business side. Like, is that like kind of a shock to them when they get out of academics?
I mean, every time I've seen it with people coming into industry, it's like, wait, do you mean that? Like, what do you mean collaborate? Like, what do I need to think of somebody else? I mean, what happens in academia is, again, if you're an academic working with other people, you do collaboration, which means that you select very specific skill sets that are close to what you're trying to do, and that's about the extent of it. But you never have to, deploy something. You never have to stress test. You never have to, bring it to production. You never have to hand it off, for your pseudocode to get to production grade level. You never have to do any of these things. And if you're, a student, it's typically, you're paired up with other people that are taking the same degree, that have probably very similar background, interest, and there is no collaboration with people that have different specific skill sets with whom you need to develop a good rapport, right? I mean, if I'm a data scientist, I am dependent on the data that I get, which means that I need to understand the job of a data engineer, and I need to figure out how to connect pipelines to my work. And it means that I need to figure out how to modify the pipelines that fit what I'm building, and then send it back and hand them off to data engineers so that they can bring them to production grade. It means that I need to hand it off, the algorithm that I'm building for scaling. Maybe I just built it with, a million rows, and this has to go to, a trillion rows. I'm not going to do that usually. There's somebody else that's really good at that, and you hand it off. So how do you hand it off? What does that look like? Like, do I just put it on a file and send it by email, or do I use version control and go through the process of environments? And, once you send it to that person, how does that process look like? So, you're starting to interact with a lot of people with very different skill sets, very specialized professionals in their field. And if you don't think ahead at how to interact with them, you're going to run into issues. And again, I mean, most people learn it on the job, like, oh, wait, I have to work with all of these people that are different from me. And, like there's protocols, there's best practices. At this point, the data science is mature enough that we've borrowed a lot of good principles from the agile methodology, from other processes for building digital solutions, and a number of other things, so that those practices are out there. But it is very rarely that programs teach these skills, and people, again, just have to go on the job and spend the first 6 months struggling to figure out how to do all of these types of collaboration. So it's a big investment in so many ways, but I mean, I'm really hoping that we move closer to that. And there are some, we can talk about it later if you want, but there's some really interesting developments that are happening to close this gap at some point. So there's a bright future ahead.
Yeah, I mean, like we've spent some time talking about the gap and the differences and what the jump from academics to your first job. And so, what are those kind of leading edge best practices? I would love to dive into that now, if that's okay. I'm really
No, no,
curious.
no, absolutely. Yeah, no, I mean, I think, and this is a little bit of why I took time off to start writing all this down, right? I mean, sort of like every data scientist that I talk to, has this same experience that I had, and we all talk about like, but why are people not taught this, or why is this missing, or things that you were like, oh, I'm the best in my company because I did this, and now we're implementing this, and you figure out that everybody's doing it too. So it's the way I really kind of like to explain some of this is think usually people think of data science as this black box made by some wizard person that just creates AI and it's like solves every problem. It's usually not like that. So the way I like to explain this, and I think it has been very helpful, is think of data science as a play on Broadway, right? I mean, any play on Broadway has a cast, right? People that have very specific and very specialized roles. Maybe you have, a protagonist. Maybe there's an antagonist. Maybe that's a support character. But you cannot just exchange them. They fulfill very specific roles. These people also act in a space, right? I mean, there's sceneries. Like they can't just act in the open, or even if they can, that you need lighting, you need better sound, you need props, you need other things, costumes, everything, right? So this is a little bit of the tools that you're using and the spaces that you're using when you're doing data scientists. There's a way to tell the story, right? I mean, you start with Act One, and Act One is divided into certain scenes. The same thing with data science. There is a whole process that starts with defining the problem and a number of these things. And in the end, I mean, this whole situation applies to whether you're, in going back to my example, whether it is the where, the why, the what, and the how all apply to, irrespective of whether you're doing a drama, whether you're doing a comedy, whether you're doing, some musical or something. It is all the same. So when you go to data science and these best practices, we're talking about specialized roles to begin with, right? I mean, you have data scientists, data engineers, machine learning engineers, project managers or product managers, and you work with other people. There is a very specific process to build data products. I mean, the I think the best kept secret of data science is that data science is about building data products that are impactful to a company. You have a company, it has a problem or a need, the data product can solve this. And that's what we do. So if we think now of data science as this a practice that builds data products that solve problems, then how do you do that? And then there's a stage where you define the problem, evaluate the data. There's a stage where you start thinking with the users about, how am I going to deploy, like what the solution looks like, how am I going to deploy it? Is it going to be maybe in a tablet? Is it going to be maybe, a website that you access? Is it going to be an email attachment? What is it going to look like? This is where the, ML side of thing goes in, where all the collaboration happens. But then there's also the next step of, you need to think and you need to evaluate ahead of time, is doing, is deploying and making the data product accessible through a cell phone, be useful for maybe my C-suite, which are my final users who, need to make really big fonts in their cell phone to look at it, just stupid things like those. They might not be able to read it or something, so maybe that's not the best way. And, how do you ensure that they use it, that they adopt it? How do you ensure that they evolve it and things like that? And across the whole process, there's also other things that we need to consider more in the technical side, right? Like, for instance, version control. At every class I teach, I talk about version control. I teach version control, and people, just start like, why are you wasting my day with this? And it's like, well, because if you don't know version control, you won't be able to do anything down
Well,
the line from handing
CTOs
it
are
off,
thankful for that. Yeah, CTOs
Yeah,
are very thankful that you're
yeah.
taking that version control. Um,
Right. Yeah. So I mean, there's a lot of things that go on, like from that to working in environments. The discipline of working from dev to staging to QA to prod for deployment. What does that look like? The handoff process, the documenting, and the working with non-technical people in the business. I mean, which is probably one of the hardest things to do for people that are really, really technical, right? I mean, I'm a math whiz, I'm a stats whiz, and I'm just going to throw my jargon because everybody understands it. And it's never the case. You have to go back to, in order to understand the problem, you have to go back to the soft skill of like, okay, let me translate what you're saying into my language, and then let me translate what I'm saying into your language, and not only the language of the business person or the person in finance or the person in the C-suite, but also my data engineers, but also my machine learning engineers that might not have my same background, in order to be able to create this solution that actually solves a problem or solves a need. So I mean, it is a complicated and broader aspect, but I think just boiling it down to this idea: the where, the what, the how, the who, gives you a good perspective on that.
Yeah, I'm thinking back to when software engineering boot camps first came on the scene 10 plus years ago. There was a lot of similarities. The difference there was their real world experience in general was even lesser because it was only like a couple months, whereas if you go to a university setting, at least you have a couple of years of
Right.
education. But there's still a lot of these similar gaps, so it's really interesting to hear you talk about this today. So let me end with a question about how the technology executives can kind of like tamper these kind of potential roadblocks, because we do need the next generation of data scientists to incorporate into the business world. We need that because especially with
Right.
AI, it's only becoming more prevalent. We're probably going to see more, college majors flock to data science. So if the gap exists, it's just going to be exacerbated in the coming
Right.
years. So how can tech leaders mitigate some of the gaps? I mean, some of it's just time. You just need to, but like in addition to that, what can they proactively do to kind of to mitigate some of the gaps between how the folks come out at the end of their academic career and then start to like kind of jump in on the business side? Give me like one or two things that you've seen work.
I'm proud to say that I think there's a couple of things that I have implemented that have been working really well, and I later found out that everybody's doing.
Okay.
Uh, One thing that I think you should definitely, if you're a tech leader, invest your time on and maybe some resources is creating dedicated data science internships. Right? I mean, you're trying to identify talent for sure, and that's a great way to do it. But the nice thing about that is that this is the first time, if you are good at that and incorporating interns into the everyday work of a data scientist or a data science shop interacting with machine learning engineers and all these things that we talked about, then these people all of a sudden just, they get the aha moment of like, oh my God, this is the whole thing of doing all of this, right? So, that's I think one very important thing, and it definitely reduces the gap because people learn really quickly, but now they know before they go back to the real world, they know what they need to focus on. Like, oh my God, I need to learn a little bit more about version control, to the point that we were talking about, or I need to know a little bit more about this or that. And I think the other thing that's always really important, and I've seen this mistake made a few times, is you really never want to start with a group of 10 data scientists or 5 data scientists fresh out of their degrees, right? I mean, it's a lot cheaper to do it. So, it
Yeah.
might make sense.
Right.
Like, okay, I won't have to pay,
Right.
FANG
Like
salaries or
hire a
something.
team of 5 juniors, they'll figure it out. Yeah, I've seen that before.
Right. Right. And then you're like, oh my God. And they're just, on your dime. They're figuring out the things that they should already know. So, if you have one seasoned person, and yes, you staff again around that with, junior people, that's a different story, because then there's somebody that can just accelerate the career paths, and any measure that you can take to accelerate those paths, like maybe, an onboarding boot camp where you like, okay, the first week I'm not going to have you on the job, but you're going to be accelerated because I'm going to teach you the hard things, and then you figure out the rest on the job, or
Right.
something like that.
Right. Yeah.
Just that's a way to go about it, I think.
Yeah. I like this mental model of, the gap exists. Sometimes the recipe is give it time, but there are things that you can accelerate. And the internship, I love it because what you didn't say, but read between the lines, is the folks in the academic setting, they're going into a business setting for, let's say, a summer or over winter break, but then they're going back to their academic setting, and now they're finishing out their academics with that peak of what it's, they're like, oh, I get it, okay, right, and then so it's like kind of a tempering mechanism, and then once
Right.
you get into the work job full time, it's, and this is true for all disciplines, but this idea of like you really, whether it's a boot camp or a senior member, someone to really kind of provide that framework for, here are the 15 things that you might not have been taught that I'm going to teach you right now, and then you can bring your expert data science skills to the table. Well, this is, yeah, this has been really eye opening, and a lot of what you said was um, kind of, I think, known, but not at the forefront of my mind. So I'm hoping other people felt that way. Like, we don't often think about these things, but as you're saying them, like, oh, of course,
Makes
right?
sense.
You're not like proactively, mitigating. You're not proactively thinking through these things. Um, so yeah, so Marco, thank you so much for doing this. I really appreciate it. It's been a ton of fun and very educational. And thank you to everyone for listening.
Thanks, David, for the questions. I had a blast doing this. Thank you so much.
Anytime.